In our last session, we added a Coinbase to our fundamental blockchain. And one of the shortcomings you might have noticed is that anyone could commit the full balance of someone else's account and pass the money on to them. Now, in order to address this shortcoming, we need to look at the concept or at the principle of private and public keys. I'm going to go ahead and navigate to a little demonstration that I have here on keys. And as you can see, a key is nothing but a long string. You can use anything you like. I could type in all ones. It wouldn't be a good key, but you could. And there's, of course, software that'll choose a sensible key for you. And as you can see there, the public key gets derived from the private key. As you can see, I'm also cycling through many keys. It costs practically nothing other than the cycles to generate it. And it is something that can be used in many different contexts. So we're going to make use of this to demonstrate first the concept of signing. Let me go ahead and navigate here to a little demonstration. And what we can do leverages the fact that private and public keys can decrypt each other. That is, if you encrypt with a public key, which is the most common scenario, only that person with the private key can decrypt. However, you can also use the private key to sign to encrypt, which hashes then encrypts, and you can distribute that as well. The advantage of that is that only the person with the private key could have generated that message, and it can be verified by everyone else since everybody else has the public key. So that's a lot of words. Let me go ahead and demonstrate it here with a little bit of code. And as you can see here, I have my message. This would be my data field. And I'm going to simply type hello. And as you can see, the same message is being typed on both. But this is the place where we're going to sign. Only I, the person with the private key, can sign. I'm going to go ahead and sign. And you can see below it the signature that was generated. Now, once we've done that, you can see here that anybody in the public space that received this message signature along with the message would be able to verify it. And in this case, I'm going to go ahead and, as you can see, let me just point out that it is the same signature. You can see it starts with 304. This one starts with 304. This is the private key on the left. This is the public key that everybody has access to on the right. And I'm going to go ahead and click and verify. And just as expected, the background turns green because I have, in fact, verified that the message was signed by the private key and it wasn't modified in transit, and only the person with the private key could have generated. Now, if we modified the message and we try to verify again, you can see that this is no longer valid. So perhaps you can already get a sense here of how we're going to use that on blockchain, but let's go ahead and walk to another example. In this case, we're going to look at a transaction. And in this case, note that the from and the to is no longer a friendly name like Abel to Catherine, but in this case, it is a public key address. From and to, it's another public key. So what we're going to do is we're going to sign this data, this transaction, going from one public key to another public key. And I'm going to go ahead and do that now. You can see there the signature that was generated. Now, when it comes to the verification, I can do the same thing as we did before and verify. And as expected, this verifies. However, if I was to turn this $20 into $200, and verify, you could see that that would no longer be valid. So as I mentioned before, we can leverage this functionality or these properties from within our blockchain. And as you can see here, I have a blockchain. Let me go ahead and make my screen a little bit smaller so you can see all of it. You can see there that I have 5 blocks. It is very much the same data that we had before, except that in addition to the transactions, I am now including signatures. That means that everybody that committed a transaction sent with it a signature, and we can confirm that that was their intent because, again, nobody but the person with the private key could have created that signature and everybody else that has access to their public, which is everyone, would be able to confirm it. So if we go here to the end and I modify this to be 200 again, you can see that the block is no longer valid, and I can mine it, and I mined it successfully. However, as you can see, the signature is invalid. Now, part of the mining function is verifying that every transaction is valid and signed, so this would be detected right away. So there we have closed the loop. And one thing that is worth pointing out is that when it came to creating an identity, we used nothing other than a public private key pair. And this, as mentioned, is inexpensive. It's practically free other than the computer cycles that it generates. And as you can see here, I am on a desktop machine, and you can see how fast I could generate these. And so we can quickly generate an identification system that can be used throughout the blockchain that can verify the intent of the person with the private key. And this is, as mentioned before, what closes out that Coinbase that we generated. And it is also the fundamental that makes up blockchain security. So with that, go ahead and push on these concepts. They can be a bit confusing at times, but it is pretty straightforward once you get comfortable with private and public keys.